Hello and welcome. I'm your host Eudoria, and today we bring you the Matrix HSC Expert webinar to provide you with tips, advice, and expertise. This webinar will help you stay on track to maximize your HSC marks. Before we begin, let's meet today's HSC expert. Today, we'll be joined by Dr. Tom Dixon, physics teacher at Matrix, with expert advice on how to maximize your marks in HSC physics. For this webinar, we recommend you have a pen and paper on hand to jot down our tips. Now that you're ready, let's get into the webinar.
Hey everyone, my name's Dr. Tom Dixon. I'm a physics teacher at Matrix and have been teaching university and high school physics for about 12 years. In this webinar, I'm going to be covering study strategies to ace HSC physics, as well as some specific study tips to ensure that you do your best in the HSC exam. This will be useful for students just starting out on HSC physics and for Year 11 and Year 12 students looking for strategies to improve their exam scores. In order to succeed in physics, you'll first need to understand exactly what's going to be expected of you for the HSC by NESA and your teachers. There are two very important documents that you should definitely read and frequently consult to ensure that you're on the right page: the HSC syllabus, including the skills section, and the performance band descriptors. The HSC syllabus outlines every single thing you're going to be expected to learn in the HSC. If a formula or concept is on that list, you can bet that it's going to be assessed somewhere and at some time. That's why we put the relevant syllabus sections at the beginning of every chapter in the Matrix textbook. You should pay attention to how each item is phrased. Do you simply need to know Planck's energy quantization? Or do you need to know how it fits within the broader narrative of physics research? Remember, the HSC examiners are going to be consulting the exact same document as you. You should read into every single detail. It's your guide to what they're going to be testing you on. The band descriptors, on the other hand, tell you how highly you should be achieving to get a particular outcome. They show you what you need to do to achieve these specific goals. These are sometimes more in-depth than you might think. For example, the phrase demonstrates thorough knowledge and understanding of scientific concepts, including complex and abstract ideas. You might expect that to be the Band 6 understanding descriptor, but it's actually just Band 5. Thoroughness is only a Band 5 trait. To get a Band 6, you actually need to demonstrate extensive knowledge. To use a specific example, let's imagine you've got a question where you have to explain the relation of Planck's energy quantization formula, E equals hf, to our understanding of light. A Band 5 response might identify that this quantization was introduced to solve the blackbody radiation problem, and that it was the beginning of the photon model, where light had distinct energy increments, E equals hf. However, you'd be missing out on a crucial and very overlooked point. When this was introduced in 1901, Planck's quantization was a pure mathematical trick to solve some annoying statistical issues with the blackbody radiation curve. It wasn't until 1905 that this formula was incorporated into the photon model of light, with Einstein's photoelectric effect. Now, while it seems like a pointless nuance, this is the kind of in-depth understanding that highlights the difference between thorough and extensive. The HSC writers will also be keeping this in mind. Remember, their job is to distinguish between students in different bands. They'll definitely be writing questions where the extensive knowledge students can be distinguished from the thorough knowledge students. This means that you really want to strive to go beyond what you think is being asked of your understanding. You need to cross from thorough into extensive. Okay, on to the most important part of this video, our 5-step cycle for studying physics, or really any quantitative subject, effectively. In brief, you should cyclically read theory, test yourself, reflect, and relearn things you did not do well on. By following this process, you will consistently increase your level of knowledge throughout the term and the year. Importantly, this cycle is all about getting relevant knowledge into your long-term memory, which is going to be the most surefire way for you to perform well in the HSC. This is not a video going to show you about cramming for a test in the last 2 weeks. You can see the 5 steps displayed right now. Learn, study, and read the theory, consolidate your understanding, application of understanding, reflection on your performance, and revision. Step 1. Learn, study, and revise the theory. It might not surprise you to learn that the first step in the process of acing the physics HSC is to learn the relevant theory. This is probably what most people think of when they hear the word study. You're going to be accessing learning materials, be it videos, textbooks, or live lessons, and doing your best to insert relevant physics knowledge into your short-term memory. It's expected, of course, that you may not retain all of this knowledge immediately. The following steps are going to assist you in understanding what parts of the course content you've retained and what parts you're going to need to study again. Now, what do you need to know to start this process? Well, whenever you're learning theory, you should have an idea of what your learning goals are. Are you taking a first pass at the material and therefore aiming for a more broad strokes understanding? Or are you focusing on a particular aspect that you don't understand fully? Are you pushing for an integrated extensive knowledge, i.e. Band 6 understanding? Or are you focusing on some quantitative method in preparation for an upcoming exam? Whatever your learning goal is, you need to identify the level you are at and be honest about the weaknesses you identify. Equally important is ensuring that whatever resources you are using are appropriate for your learning goals. For example, if you're looking to get a Band 6 extensive understanding of the HSC syllabus content, you need to make sure that you're using a textbook that goes to an appropriate level of depth. Now, your study doesn't necessarily have to be from textbooks or from dry videos. For example, if you're trying to learn the correct sequence of events from the Big Bang up until today, finding a cool infographic or YouTube video is going to be much more engaging than simply reading a few paragraphs of a textbook. Physics is supposed to be interesting and cool, so make sure you take the time to study the fun things. At Matrix, we help you with this theory stage with our in-depth textbook and teachers who explain complex ideas clearly and accessibly. Our physics theory books and workbooks are written by actual physicists, like myself, and are intended to get you to a Band 6 level of understanding. Remember, extensive knowledge, not just thorough. Step 2, consolidation. Of course, learning from the best resources and teachers is not worth anything unless you consolidate your understanding with further exercises and self-study. I often tell my students that you need to convince your brain the information you've learned is worth retaining. The best way to do this is to do homework tasks that rely on the information that you have just learned. What you need to be doing is attempting to utilize and recall the information you've learned. In this manner, you're going to be much more likely to consolidate it. Now, an important part of the consolidation process is time. I always tell my students that one of the worst times to do your homework is right after class. This is because the content is already in your short-term memory. Instead, what you must do is allow the content to leave your short-term memory, perhaps by focusing on something else, and then only attempt your homework and revision exercises after. This will force your brain to retain this information in long-term memory. We call this distributed practice, and it is by far the most effective way to consolidate learning gains. There's a lovely research paper explaining this process linked in the description below. At Matrix, we help you with the consolidation step by preparing a wide range of homework and self-study resources in our workbook. These resources are written specifically to target the relevant learning outcomes of the HSC syllabus. By working through them, you're going to be forcing your brain to consolidate the learning gains made in the previous step. Remember, it's okay to be looking through the theory book at this stage. While you are training your long-term memory, there's no way you're going to remember everything on the first try. Step 3, application. Where it's not okay to keep the training wheels of matrix theory books, textbooks, and other resources is the application step. In this stage, you need to replicate as closely as possible the environment in which you expect to demonstrate your knowledge. For most of you, this means attempting HSC-style examinations under exam conditions. Now, the under exam conditions part is really important. You need to be making as genuine an attempt as possible. The reasons for this are twofold. First, you want to be accustomed to and comfortable with, as much can be achieved, the HSC test environment. The HSC is by nature stressful and, for most students, anxiety-inducing. But the real deal will be even more challenging if you don't have any experience in these types of environments. By undertaking repeated practice under these stresses, you'll become more comfortable in formal exam settings and less likely to suffer the adverse effects of test anxiety in real-world exams. The second reason is to allow these applications to function as meaningful assessments. Remember, the purpose of this stage is to assess your current level of knowledge retention and demonstration. It's about how much you know right now, not about how much you can look up from your textbook. This also means that your exam performance in these dry runs is not necessarily that important. It's intended to be formative assessment. Now, what is formative assessment, I hear you ask? Well, formative assessments are tasks that provide useful guidance and feedback that allow you to further improve in your studies. This is distinct from what you'd call summative assessment, where you are given a final score and no chances to improve. Now, summative assessment, the only example we're going to have of that is the actual HSC trials and examinations. At Matrix, one of the ways we help you in authentic assessment is via our weekly quizzes. These are short, HSC-like quizzes designed to test your attention of the previous lesson under exam conditions. Importantly, they're a diagnostic tool. The purpose is not to get a higher mark than your friends, but to see what areas you're strong in and which areas you need to focus on. Step 4, reflection. Following application, it's important to reflect on your own performance. In which parts did you do well? In which parts were you lacking? Unfortunately, it's not enough to complete some practice assessments under exam conditions. You need to examine your performance to see what you can improve on in the future. This could be as simple as, I don't understand this topic, to higher level issues like, I can't structure 7-mark questions very well. Whatever your issues, make sure you take note of them so you can improve upon them in the next stage. An example that comes from my personal experience is poor structure for large mark questions. My answers are often all over the place, jumping between time periods, concepts, as new ideas come to my mind when I write. After doing this enough times and having teachers say they didn't understand what I was trying to say, I realized that I needed to focus on structure. I knew all the relevant facts, but I couldn't put them in an order that made sense to a reader, especially one who was probably reading hundreds of different responses to the same question. So I made a note of that, and the next time I had an essay question, I made sure to stop and write a mind map to structure my ideas before beginning the essay. It's also important to identify where you went wrong and why. Is there a fundamental misconception that you possess? Was it a simple calculation error? Or do you simply not have enough understanding at the moment? In these circumstances, while you probably know yourself better than anyone, it's a good idea to talk to peers and teachers in order to gain valuable feedback. Often, it's very difficult to self-diagnose physics misconceptions. At Matrix, we have our teachers grade your quizzes and generate feedback specifically to provide this external perspective. Because all of our staff are highly experienced teachers, we already know all the common misconceptions and bad thought patterns for a given topic. Make sure you pay attention to the feedback for your weekly quizzes, not just the mark, and ensure you take these lessons to heart. In no time, you'll see a substantial improvement. Another useful tip is for you to record any mistakes and misconceptions alongside corrections in what we call a fail book. Now, what's a fail book? Well, it's not a book categorizing all the failures in your life. No, FAIL here stands for First Attempt in Learning. And in it, you'll record particular issues that you've identified in your application of physics. It could be that you don't remember how to do projectile motion, or that you get bogged down in algebra on long questions. Whatever it is, make sure you record it. By making a concise summary of your issues in understanding, you'll put yourself in a good position to improve efficiently upon further study. And you'll also get to look back and appreciate how far you've come once you get a few cycles of study in. Step 5, revision. The final step in the process is revision. Having identified all the areas in which you are lacking, it's now time to go back and relearn the content. Here, it's important that you were engaging in authentic assessment of your capabilities back in step 3. If you looked at a question and thought to yourself, yeah, I can do that question, that's not necessarily an indication that you actually could. It's also important to be strategic. If you found the entirety of a topic difficult, then you will probably not get to expert level in just one more cycle. Set yourself a realistic achievement goal, maybe getting a certain mark or a certain percentage of a type of question correct, and then begin the theory step again, focusing on the things you specifically want to improve. In time, you'll see a substantial improvement in your physics capabilities. Holiday versus term course. So, how can Matrix help? Well, at Matrix, we've got a lot of collective experience in helping students effectively follow these study procedures. As a Matrix student, you have two options in how you approach your study, the term course and the holiday course. The term course is the standard Matrix course. Students take one lesson each week, completing the homework throughout the week, and then completing a test on the previous week's content at the start of each subsequent lesson. This format allows you to keep a similar pace between Matrix's lessons and your school's lessons, and also provides more time for the content to sink in. This is especially effective if you have good study habits and are regularly revising the material. In a term course, you'll more organically progress along these 5 stages. Each week you will learn some new theory, consolidate it via homework, and then be encouraged to apply your knowledge in the weekly quiz. Reflection and revision will happen throughout the term as you get your quiz and other feedback from your teacher. The holiday course is structured a bit differently. All 8 Matrix lessons are delivered over a span of 2 weeks, essentially completing the entire theory step in one go. Now, while it's important that students complete their homework as much as possible during this intensive fortnight, the effectiveness of the consolidation step here is not as high as it could be in term courses. This is simply because you're going to be trying to do in 2 weeks what others do over 2 months. The overwhelming benefit, however, is that you can spend a long time testing and revising during the school term, reflecting and revising your understanding, giving yourself more time to establish a truly deep understanding necessary to get a band 6. Okay, so now we've got a general strategy out of the way, I'm going to discuss some more general tips, including some of my personal favorites that will help you succeed in the HSC. These are sort of consolidated from my own experience teaching HSC and university physics, as well as a general synthesis of lessons learned by some of our matrix students. Firstly, you should be able to understand each physics formula qualitatively, as well as being able to use it quantitatively. Here, I'm referring to your ability to explain to someone what factors affect a certain quantity. For example, if I asked you what factors affected the kinetic energy of an object, you would ideally remember that the object's mass and velocity are both important. If pressed, you could probably say that the velocity is more important because kinetic energy scales with velocity squared. So why do you need to be able to do this? Well, 2 reasons. Firstly, this kind of qualitative understanding is an easy way to check that you have extensive knowledge of the subject matter. If you can explain what a formula means, you're not just plugging and chugging, you're actually understanding the physics behind the formula. Secondly, there are a lot of questions in the HSC and other exams where you're not given enough numerical information to solve an equation, but are still asked to predict what would happen if a certain variable is changed. As a quick example, let's look at Newton's law of universal gravitation. Even if you don't remember the formula explicitly, you can quickly reconstruct it if you remember it qualitatively. For example, I remember that the gravitational force between 2 objects is proportional to both their masses multiplied together and inversely proportional to the square of their separation. From here, if I forgot which exact formula to use, I could quickly check the formula sheet to see which one matches my description. Let's say I'm then asked the following question. The gravitational force of attraction between 2 objects is 100 newtons. What would the force of attraction be if one of the masses was doubled? Now, there's not enough information here to numerically use the formula. We don't know R, and we don't know either of the masses. But we do remember, hopefully, that the force is proportional to the 2 masses multiplied together. If one of the masses were to double, then the product of the 2 masses also doubles, and therefore so too does the force. We could then answer 200 newtons. You've probably heard that in the later stages of the Year 12 syllabus, we'll begin to deal with some really interesting and complicated concepts. Quantum mechanics, special relativity, and the Big Bang Theory. While in reality these fields are incredibly complicated and require super difficult mathematics to understand, in the HSC we have a very substantial advantage. The maths is so difficult that it's completely outside the scope of high school. This means that for most complicated aspects of the physics HSC, your understanding will be qualitative and mostly narratively focused. Now this means you can get a similar level of understanding from the HSC level of quantum, relativity, and cosmology from pop science books and YouTube videos, similarly to what you would get through schooling. You don't need to worry that the books or videos are oversimplified because the HSC is equally oversimplified in this circumstance. In fact, the principal difficulty in these sections is understanding all the different experiments, theories, and discoveries, and then kind of putting them together in a cohesive timeline. If you get started on reading or watching some of these books and videos ahead of the modules 7 and 8 in school, you'll be in a very good position to understand the content and succeed in tests, especially as most of them will involve written explanations. I've included some nice video and book recommendations in the description of this video. For better or for worse, the principal way in which we demonstrate our extensive understanding of the physics HSC syllabus is via tests and exams. This means that your ability to perform in an exam becomes an important factor. What I'll do now is share a couple of tips and tricks I use to maximize exam performance for a minimum time cost. Now, time cost here is really important. You could, for example, double check every single calculation you make, but this would chew up valuable time that could be spent on long response questions or tackling the harder calculations. Instead, I prefer to focus on the most time efficient methods. The first point takes advantage of something very useful about HSC physics in particular. The questions, for the most part, take place in the real world, using the same real-world constraints and variables that you use in everyday life. This means that for the most part, the answers to certain questions can only take certain ranges. If you know the range of possible values an answer can have, you can quickly ascertain if you've made a mistake in your calculation. Let's do a projectile motion example. Say that I asked you to calculate the time of flight for an object that's falling 200 centimeters from rest above the ground. We'll use the formula s equals ut plus half at squared and quickly rearrange to find that t equals the square root of s on 2a. Substitute in s equals 200 and a equals 9.8 and you'll get around 3 seconds. But hold on, we know from physical experience that it doesn't take 3 seconds for something to fall 2 meters. This conflict between what we got from our equation and what our intuition tells us from prior experience leads us to investigate further. Hopefully you saw there that I forgot to convert the 200 centimeters to 2 meters. By comparing the calculated result to our knowledge of the physical universe, we were able to quickly identify that we had made a mistake in the calculation. Now this is all well and good for things we have physical experience of, projectile motion, simple forces, etc. But in order to maximize the utility of this technique, you should actively build up a mental database of values for both experiential and non-experiential quantities. The more comprehensive your mental database is, the more circumstances in which you'll be able to quickly assess for mistakes. Let's take a look at a couple of my personal favorites. Low Earth orbit. So low Earth orbits always have an orbital velocity around 9 to 8 kilometers per second and an orbital period of around 90 minutes, along with an orbital altitude of 400 to 1,000 kilometers. Using this, it's really easy to identify some erroneous calculations for LEO satellites, like in this example. As you can see, calculation D is not what we'd expect. This is a sign that we should investigate and double check this calculation. Photoelectron energy. This one is a 2-for-1. The energy of a photon of visible light and the energy of a photoelectron ejected by visible light are both on the order of single-digit electron volts. This can combine with some atomic models of the atom to tell us that the difference in electron energy levels is also around single-digit electron volts, especially for energy jumps that emit visible light. By remembering that 1 electron volt is around 10 to the minus 19 joules, we can also mentally store these values in joules. Expectations on answers. The second exam tip is somewhat related to the first. You should always have an expectation of the outcome of a calculation before you perform it. In the simplest case, this means consulting your mental database of values. However, this only gets you so far. It's a good idea to use the details of the question and your qualitative understanding to place expected bounds on your answer. Let's use a simple example, Ampere's force law. We have one wire, X, with 2 amps of current, placed in between 2 other wires, Y and Z. The current in all the wires is flowing in the same direction, and therefore we know that wire X will be attracted to both wire Z and wire Y. Now we're told that the current through wire Y is 4 amps and that it's 20 centimeters away from the wire. We're then asked, if wire Z is 13 centimeters from wire X, what current will it need so that the net force on wire X is 0? Now, before we calculate, we can put some expectations on our answer. We know that wire Z is closer, but it needs to exert the same force that wire Y did. Therefore, according to Ampere's force law, wire Z should have less current than wire Y. We're expecting an answer less than 4 amps. However, we also know that wire Z is more than half the distance from X than Y is, meaning that, provided we understand that the Ampere force law linearly decreases with distance, the current in Z must be more than half that of Y. Without doing any calculations, therefore, we figured out that the current in wire Z should be between 2 and 4 amps. And if we do a calculation that yields a different answer, we should recheck. Now, it's important to do these quickly in an exam. If you spend just as long figuring out appropriate bounds as you do calculating, then you aren't doing yourself any favors. Ideally, you should have these expectation bounds within a few seconds of looking at the question. And this means you need to practice. Practice a lot. My personal favorite way to practice this actually works well in pairs or groups. Each person gets allocated a series of calculation questions that they complete in a very short amount of time. Importantly, they don't need to get these questions correct. Instead, each student swaps their question and answer sheet with another student who, as quickly as they can, guesses if the student's answers are right or wrong based on their instinctive understanding of formulae or their mental database. Now we've reached the end of the video. We've covered a lot, but what was the most useful piece of advice? Tell us in the comments below. To summarize the key points, At Matrix, we encourage and assist our students to learn physics using a 5-step cyclical process of learning, consolidation, application, revision, and reflection. By applying this process through either our term or holiday courses, you'll be able to make more steady and quantifiable progress towards achieving your physics goals. We also discussed that it was important to know what these goals are, to be familiar with both the syllabus and the band descriptors so you know exactly what kind of knowledge you need to demonstrate. And finally, I shared some personal tips that I know will help you up your game for the HSC. That's all for now. Hopefully I'll see you around campus or in my next video.
Thank you for attending this Matrix HSC Expert webinar. We hope our webinar has left you with the expert knowledge you'll need to study effectively. For more useful HSC content, click the link above to visit the Matrix Education blog and make sure you subscribe to our YouTube channel. We look forward to seeing you at our next webinar, and best of luck for the HSC.